Good afternoon. My name is Curtis Dunn, and I work for the North Dakota Department of Transportation in the Grand Forks District, and my position is the Highway Material Coordinator. And I'd like to talk to you today about percent within limits, and it's a new specification that we've tried on a couple of projects now in the last couple of years. And I think it would be interesting to go over some of those things that we learned for those who are going to have a project with us in 2023. To start out with, there's in anything we do, especially in civil construction, is there's some inherent variability, and it's in the raw materials that we have in our gravel pits and in our quarries. And there's variability introduced into the process when the contractor actually starts to process the material so that it's suitable for to go in our projects. And also the testing that we do, there's always a little bit of variability, and also sampling. So when you take all those four things, it actually adds up to be a fair amount. And so with that in mind, since there is variability present, it's essential to account for it, to be fair. And the method that needs to be able to measure, quality needs to capture variability efficiently, and it needs to appropriately tie a payment to that statistically valid measure of quality. And so that's where percent within limits come in, because everything is under a normal distribution, and percent within limits works on that basis. And so it's an improved way to measure quality in asphalt pavements. PWL uses both a mean or average and standard deviation, which is the range of your data, of a data set, to determine the percentage of the paving lot within the specification limit. It efficiently captures both in one pay factor and in one formula. It captures both the average or mean and standard deviation in a single quality measure. A PWL specification encourages the contractor to produce a more uniform product. So not only do you want average, which for years now we've been working with averages, but it really doesn't really tell you too much about the quality or the uniformity of the product. What it's really doing is trying to keep that standard deviation very low, but also have a very good average as well. And so it actually encourages the contractors to produce a more uniform quality product, and it offers rewards or penalties depending on the quality of the work produced. So as I was mentioning earlier, in a lot of our traditional specs, we always just look at average. And in the past, and this was maybe before incentives, the contractor, can receive payment for meeting density when many of the quarries could potentially fall below the desired target value. A lot of our projects have 91% density and 92% density. Well, if you can get an average of 92, that means that there could be a lot of quarries that are actually under that minimum. The asphalt paving workbook has been now adjusted to accommodate percent within limits projects. And we're not really going to go over the paving workbook per se here today, but I thought it would be interesting to go through some of the calculations just by longhand, just to see what's actually going on and what the paving workbook is actually calculating. And there is a special provision. If you have a project this year and there's going to be percent within limits on it, it'll be in the form of a special provision. And in that special provision, there is not only instructions about the percent within limits, but there's also a set of calculations that are used too, that are actually in the appendix, and a table that goes along with it that we'll see a little bit later here. These calculations are actually the exact same ones that the paving workbook actually uses to calculate the PWL on the projects. So I'd like to go over these briefly, each step here, and just actually work out an example that we did on one of our projects on Highway 1 this year. And so the first part was here that there's a set of cores over to the right. We had, for a typical day here on August 11th, we had 21 cores. And so the first step is to actually get an average of those. And basically that's just, totaling them all and dividing by the certain amount of cores that were there, and that'll give you an average. The next step is probably the most complex step of the whole process here, is just getting a standard deviation, and that's basically a statistical formula. And you actually use the summation of the squares of the individual test values. You also use the summation of the individual test values squared, and then you use your total number of test values from the lot. And so you can actually calculate a standard deviation. And this is what really kind of the second part of the whole thing of the specification, because the lower you can get this number, the better off you are. If you have a high standard deviation, that means you've got a lot of variability out there, and that's something we're really not looking for. So once you've calculated the standard deviation and the average of your cores, you can go ahead and figure, some of the other calculations. There's what they call an upper quality limit, which is a Q sub U, and the lower quality limit, which is a Q sub L. And in that formula, you actually use your upper specification limits and your lower specification limits. Now, for percent within limits projects, the lower specification for density is 92%. And the upper specification limit is 97. So you actually use these formulas use these values in these formulas, and you actually can calculate the upper and lower quality limits. So with that, now you can actually go to a table, and this is a statistical table. This is a pretty universal table for figuring out percent within limits. And this table is actually also in the special provision. And what we're going to do with these upper and lower quality limits is to determine the percent within limits in the upper end and the lower end. And it's hard to see this table, so I've actually made one that was more close up here. So we're going to bring the numbers that we had in the previous page here for the QLs and the QUs. And we're going to take the column here that represents the number of cores we have. In this case, it was 21. So what we're going to do is we're going to take these numbers, the Q sub L and the QU, and we're going to find those numbers on this column, and then we're going to go directly to the left, and that's going to give us our PWL numbers. Now, sometimes they're not going to be exactly 100 or 99. There might be some decimals there involved. So you may have to interpolate a little bit on that. So what we ended up with here was a 99.5 and a 95.7. And if we go to the next page now, we can actually do some figuring out here what the actual quality level is, or the PWL for it. And in this case, if you bring these numbers from the page before and you plug them into the formula here, as we did here, you'll end up with a 95.2, which is a pretty good number. Now, the only thing left now to do is, once you've got a quality level, is to be able to plug it into the PWL pay factor, which is also used in the paving workbook. And this is a pretty universal formula that's used all over the United States. It's 55 plus 0.5 QL. So in this case, we're going to plug in the 95.2, and we're going to end up with a pay factor of 102.6. So in this case, the contractor for the day here is actually going to be getting an incentive out there for the quality of work that they've done. The most pay factor you can actually get is 105 as far as incentive is concerned. And the only reason that the contractor really didn't get that here is because one of the cores are actually over 97.3. And so that kind of, brought, since it was out of the limits here, it actually there wasn't as much pay factor. But you can see from just looking at this that the average, which is the top of the curve here, is well beyond the 92 limit, and it's actually fairly narrow. So you could see that the more spread you have, or the flatter this curve is, that means that you've got more standard deviation. That's something you don't want. Overall, on this particular project, of all the days we did, I just took all the cores, and there was 221 mainline cores. There was an average density of 94.8. The minimum core density was 90.8, and the maximum core was 97.5. There were 6 cores that were under the lower limit and 5 that were over it. And if you plug that into the formulas we just went through, it ends up with a pretty nice curve here. And actually 97.3% were over 92%, which is very good, I think. And so I think from percent within limits, we can, look at, I think what it's actually doing is it's actually pushing our averages farther to the right, but also still giving us some very good uniformity. If our curves were really close to the 92, the closer you get to either the upper or the lower, you're going to want less variability, as you can see. So that's all I have, and I appreciate thank you for the time today, and have a good day.